Today we're going to talk about dividing polynomials, but let's start with multiplying. You might want to hit pause if you haven't done this yet, and go ahead and multiply that out. All right, so the key here is you have to distribute. A lot of times people remember the term FOIL, and that's when you're multiplying two binomials, something like this. Okay, but what we're actually doing when we FOIL is distribute. So we have to multiply everything in one set of parentheses times everything in the other set of parentheses. So I'm going to have to multiply this x by 2x squared, and that's going to give me 2x to the third. And then x times negative 4x, and that gives me negative 4x squared. And then x times positive 5, and that gives me 5x. Now I have to multiply the negative 2, times everything. So negative 2 times 2x squared gives me negative 4x squared. I'm going to write that underneath the other term that has an x squared. And then I can combine like terms easier. And then negative 2 times negative 4x is a positive 8x. So I'll write that underneath the 5x because those are like terms. And then negative 2 times 5 is negative 10. There's no constants in the other one. And so then what I'm going to do is I'm going to add these together. And I'm going to get 2x to the third power minus 8x to the second power plus 13x minus 10. And that's our answer. So that's the product of this binomial with the trinomial. Seems easy enough. What if I asked you to divide 8,946 by 42? So I could have just written this as a fraction and said divide. Or, if you remember way back in the day, when you learned long division, this is how we did it. And you'd put a decimal point here and put it up there. But we're not going to worry about the decimal point here. We're just going to talk about the remainder if there is one. Okay, so what we're looking at is, let me box that off. We're going to look at 42, and it doesn't go into 8. So then we take the next digit, 89. Does it go into 89? Sure. It goes in there twice, and there's going to be some left over. So let's do this in a different color. How about purple? So 42 times 2. So then I multiply. I think we need an arrow here so you can see where I'm looking. So then I'm going to multiply 2 times 42 and put the answer down here and subtract. So 2 times 42 is 84. We draw a line, parentheses, subtract. I know you don't need the parentheses, but you'll see why I'm doing that later on. And then you do 89 minus 84, and you're going to get 5. And now 5 is smaller than 42, so 42 cannot go into 5, so we have to bring down the next digit, which in this case is a 4. So we'll bring that down. And so now we're going to ask, how many times does 42 go into 54? Well, that's a pretty easy question. That would be once, so I put the 1 above the 4. And then I multiply, once again, 1 times 42, put the answer down here and subtract. So 1 times 42 is 42. Draw a line, parentheses, subtract. 54 minus 42, that's 12. Once again, that's smaller than 42, so 42 cannot go into 12. So now what I'm going to do is bring down the next digit, which is a 6. So now that becomes 126. How many times does 42 go into 126? Well, twice was 84, and another, that makes 100. Oh, works out perfectly if I have 3 of them. So 3, and then once again, I multiply that 3 times 42, put the answer under here, and subtract. So 3 times 42 is 126. Draw a line, parentheses, subtract. And we have 0 remainder. So the answer to this problem is 213. Now that's pretty easy to check. We could multiply 213 times 42 and see what we get. At least I was using x instead of a dot. and multiply and see what we get, and you'll see that you are going to get 8,946. Okay, that process is really, really important to understand, and it's probably been forever since you've done that. But that's key to what we're going to do today. All right, before we talk about real zeros of polynomial functions, we have to get really good at division. So, I would like you to divide the polynomial 2x cubed minus 8x squared plus 13x minus 10 by x minus 2. So we're going to set this up exactly the same way. We're going to put the x minus 2 out here, and then the 2x cubed minus 8x squared plus 13x minus 10. All right, so the key for this, let's draw my arrow because that's going to be important, is we look at the highest power term here, the highest power variable in this term here, and then what do we have to multiply that by to get this first term? So what do I have to multiply x by to get 2x to the third power? And the answer to that would be 2x to the second power. And actually, let me move this over. I'm going to write it actually over here. Notice I'm writing it above the x squared term, and that's not essential. You can put it over here, but I like to stay organized like that. So now, just like we did before, we're going to multiply 2x squared times x minus 2. We're going to put the answer down here, and we're going to subtract. Okay, so 2x squared times x is 2x cubed. That's why we're doing this, so that leading term is going to cancel. And then 2x squared times negative 2 is negative 4x squared. Draw a line. Here's why I put the parentheses earlier, and subtract. I don't want you to forget to subtract the other terms besides just the leading term. All right, so now 2x cubed minus 2x cubed is 0. Those cancel out. Next we have negative 8x squared minus a negative 4x squared. So negative 8 plus 4, what's that going to give us? Let's switch colors here. So that's going to give us a negative 4x squared. Bring down the next term, 13x. Okay, now we're looking back up here. This is x to the first power. What do I have to multiply that by to get negative 4x squared? And then I'm going to write it up here. So x, I have to multiply this by negative 4x to the first to give me negative 4x squared. So negative 4x to the first. Now take that negative 4x and multiply it by x minus 2. And when I do that, negative 4x times x is negative 4x squared. It should match the one above it. That's why I'm doing this, so those cancel. So I'm canceling things one at a time, working my way from left to right. And then the negative 4x times negative 2 is positive 8x. Draw a line, parentheses, subtract. Okay, so when we subtract this, the negative 4x squareds cancel, and then I have positive 13x minus 8x. That's going to give me a positive 5x. And then bring down the next term, which is a negative 10. So now I have 5x minus 10. And now I go and look back up here. This is x to the first. What do I have to multiply this x by to equal 5x? And that's going to be 5. So I'm going to write that over here. So that's going to be plus 5. And then I'm going to multiply that 5 times x minus 2, put it under here, and subtract. And when I do that, 5 times x is 5x. And 5 times negative 2 is negative 10. Draw a line, parentheses, subtract, and I get 0. So that means there's no remainder. So my answer is 2x squared minus 4x plus 5. Right there. Which means if I multiplied that times x minus 2, I would get 2x cubed minus 8x squared plus 13x minus 10. Let's get rid of that. Don't need this. All right, so there's your answer. Let's try another problem. And this would be a good one where hit pause, try it yourself, and then come back and check. All right, so let's divide this. Now I'm going to start working a little faster here. You've got the idea. There's one trick to this one, and that is we're missing an x to the first power. Oops. That's supposed to be an x to the third there. X to the third minus 2x squared. So I have to write in plus 0x minus 9. So if you're missing a power of x, you need to write these in descending order, and if any are missing, you need to put a 0 term in there for that spot. That's really important. X minus 3. Okay, I'm looking at the x outside and the x cubed inside. I have to multiply that by x squared. X squared times x minus 3 is x cubed minus 3x squared. Draw a line, parentheses, subtract. I'm going to get negative 2x squared plus 3x squared is a positive 1x squared. Bring down the 0x. Okay, what do I multiply x on the outside by to get x squared? Well, that would be a plus x. So multiply that x times x minus 3, and I'm going to get x squared minus 3x. Draw a line, parentheses, subtract. The x squareds cancel. 0 minus a negative 3 is 0 plus 3, so I get 3x. Bring down the next term, minus 9. What do I multiply that outside x by to get 3x? That would be a plus 3. Multiply that 3 by x minus 3, I get 3x minus 9. Draw a line, parentheses, subtract, no remainder. So that tells me my answer is x squared plus x plus 3. Which means, by the way, just to highlight what we're figuring out, that means that x squared plus x plus 3 times x minus 3 will equal x cubed minus 2x squared minus 9. Okay, so in effect, I'm factoring my polynomial. All right, there's another way to do these sometimes. So this doesn't always work, but it's a shortcut. So I'm going to walk you through that. And so what we just did, this is called long division. There's another technique that we can use called synthetic division. And we're only going to be able to do that when the polynomial that we're dividing by is a binomial with x to the first power plus or minus a constant. Then we can do synthetic division. And so here's how this works. I'm going to need an arrow so you see where I'm getting my numbers from. So what I'm going to do is I'm going to put a little box, and then I'm going to take the opposite of the constant. So since that's x minus 2, I'm going to put a positive 2 in the box. So you're always putting the opposite of what that is. Then what I'm going to do is write just the coefficients of my polynomial. So a 2, a negative 8, a 13, and a negative 10. And I'm going to write those across here. So I'm getting these from the original polynomial. So that was a 2, a negative 8, 13, negative 10. And then I'm going to draw a line down here. I'm going to put a little line here. All right, we're ready to go. So first thing I'm going to do is take this number here and bring it straight down. So we got a 2. Then, I don't like my arrow. Let's change my arrow because I want it to point this way. All right, then what I'm going to do is take the number in the box and multiply it by that number and put it here. So 2 times 2 is 4, so I put a 4 here. And then I'm going to add those two numbers in that column. Negative 8 plus 4 is negative 4. So I brought the first number down, multiplied by the number in the box, put the answer over here, added these two numbers together, I get negative 4. And just repeat that process. So multiply negative 4 times the number in the box, Put that answer here, and then add it to 13. This is like magic. Negative 4 times 2 is negative 8. 13 minus 8 is 5. And then repeat that process one more time. Take that answer 5, multiply by the number in the box, put it over here, and add it to negative 10. So 5 times 2 is 10, negative 10 plus 10 is 0. And so the reason I put this vertical bar here is this is the remainder. And so that tells me 0 means there's no remainder. Now look at the answer. A 2, a negative 4, and a 5. What does that mean? Well, those are the coefficients of our answer. Now if the original polynomial, here's my arrow, this 2 referred to an x to the third power, right there, and this 2 was the coefficient of x to the first power, then I know when I divide, that x to the third power is going to get lowered by 1. So this is going to become 2x to the second power. So the answer is always going to be 1 degree less than what we divided into. So I know my answer then is going to be 2x to the second power minus 4x to the first power plus the constant 5. And lo and behold, that's exactly what we got there. And I know what you're thinking. Oh my gosh, that was a lot easier. Yes. And so it's important to be able to do both though. And the reason being is because we're not always dividing by a binomial which has x to the first power. You should be able to do division by trinomials or terms that have x to the second or to the third. So long division is going to be the only way to go for some of those problems. So it is important to be able to do long division, but it's nice to know we have synthetic. So let me walk you through synthetic one more time with this example, and this time I'll go a little more quickly. And so we have x minus 3, so we put a box. The opposite of minus 3 is positive 3. Then we look at our coefficients of x cubed, that's a 1. X squared is a negative 2. There's no x to the first power, so I have to put a 0. Don't get caught there. And then the constant is a minus 9. Draw a line down here, put a little vertical line there for our remainder section. And here we go. Bring the 1 down, multiply by 3 in the box, put it in the next column, add those together. 1 times 3, put that there. 0 plus 3 is 3. Multiply by the number in the box, we get 9. Add those, we get 0. So there's no remainder. My initial one was an x to the third. So I know that my answer will be an x to the second. So 1x to the second plus 1x plus 3. Or in other words, we would just write x squared plus x plus 3. And oh my gosh, that's exactly what we got using long division. Okay, I know it's kind of taken a while to explain, but it's really easy once you get in the rhythm of it. Let's look at this type of problem. One of the factors of 6x cubed minus 19x squared plus 16x minus 4 is x minus 2. Factor this polynomial completely. So I want to take this and factor it. And we've learned a few tricks over the years on how to do this, but there's nothing that we've probably learned so far that helps us figure out how to factor that. But by me telling you x minus 2 is one of the factors, well, that's very helpful. Because I can divide that out of this, and then I'll be left with some quadratic, and maybe I can factor that quadratic. So that's what we're going to do. So I'm going to use synthetic division here. Actually, since I just did synthetic, let's do long division, because you probably don't want to do it that way. And this will be fun. 6x cubed minus 19x squared plus 16x minus 4. And I'm just going to go, you might want to hit pause and try it yourself first. So I need to multiply the x by 6x squared. 6x squared times x minus 2 gives me 6x cubed minus 12x squared. Draw a line, parentheses, subtract. Negative 19 plus 12 is negative 7x squared. Bring down the next term, 16x. I need to multiply the x by negative 7x, and that gives me negative 7x squared. And then negative 7x times negative 2 is positive 14x. Draw a line, parentheses, subtract. First terms cancel. 16 minus 14 is 2x. Bring down the next term, which is a minus 4. What do I multiply x by to get 2x? A positive 2. Multiply 2 times x minus 2, and I get 2x minus 4. There's no remainder, which there shouldn't have been since they told me it was a factor. So this is the other term. So far, here's what I have. 6x squared minus 7x plus 2 times x minus 2 is equal to this cubic polynomial. So now, if I can factor that quadratic, I have completely factored this. You might want to hit pause again and try to factor this yourself. All right, 6x squared, it can be a 6 and a 1. I'm going to guess it's probably a 3x and a 2x. And then to multiply the other two, I have to get a positive 2. So if I put the 2 here and a 1 here, and made them both negative, then my inside terms give me negative 4x, the outsides give me negative 3x, and that together adds to negative 7x. So I know I did it correctly. All right, and you may just need some more practice with factoring. But there's our final answer. That's the completely factored form of this cubic. And you could have used long division, synthetic division instead of long division to get the quadratic. All right. One last idea. We have never had a remainder yet. So what happens when we get a remainder? So for example, if I do this, 17 divided into 1,108. 17 doesn't go into 110, it doesn't go into 11, but it goes into 110. Let's see, what would that be? Maybe 6 times? 1642, I believe. So 6 times 17 is 60, plus 42 is 102. Subtract, we get 8. Bring down the 8. 17 goes into 88. Let's see, 5 times, I think. 5 times 17 is 50, plus 35 is 85. Yep, that works. And I get 3. And that's smaller than 17. There's nothing else to bring down, no other place values to bring down. So that's my remainder. So you may have written this in the past like this, 65 remainder 3. The way we're going to write it is we're going to write it as 65 and 3/17. So we're writing it kind of as a mixed number. So we don't want to use the r. We're just going to use a fraction for our remainder. So whatever your remainder is, you make a fraction with that and this number here, 17. All right, so now let's try that with a polynomial. Notice I can't use synthetic division on this, by the way. So that long division is important to be able to master. All right, so I'm going to put 6x to the 4th. So top goes inside, minus x squared plus 9x minus 3. I promise we're almost done. X squared plus x minus 1. All right, here we go. X squared, I want to get 6x to the 4th, so I need a 6x. I'm going to move this way over. I need a 6x squared. Let's multiply 6x squared by everything outside. I get 6x to the 4th, which is what I wanted to do, plus I get a 6x cubed, and then I get minus 6x squared. Draw a line, parentheses, subtract. Negative x cubed minus 6x cubed gives me a negative 7x cubed. Negative 1x squared plus 6x squared is going to be a positive 5x squared. Bring down the next term, which is 9x. I want to get rid of the negative 7x cubed, so I'm going to have to multiply this, the number of the polynomial outside, by a negative 7x. Multiply that by the x squared plus x minus 1, and we get negative 7x cubed minus 7x squared plus 7x. Draw a line, parentheses, subtract. We're going to get 12x squared. 9 minus 7 is 2x. Bring down the minus 3. That's squared. Okay, I want to get rid of the 12x squared, so I have to multiply x squared times a positive 12. That's going to give me 12x squared plus 12x and minus 12. By the way, just yell if I make a mistake. Oh wait, I wouldn't hear that because you're listening to this. And those cancel, 2 minus 12, so I get negative 10x, and then plus 9. That's my remainder. So I'm going to take that and put it over the x squared plus x minus 1. So when I divide, the answer to this is going to be 6x squared minus 7x plus 12 plus my remainder, negative 10x plus 9, over what I was dividing into, the x squared plus x minus 1. And so that's how you handle it when you do division of polynomials and you have a remainder. Okay, practice is the only way to get good at this. It starts off slowly probably, and then after you do some, you'll start to get very, very fast at it. And so here's the assignment. The first part of this section starts on page 124.